Hey everyone. Um, as per usual, let's give a few minutes for people to trickle in. But on the agenda today, we have the wallet account experiments team that's going to be giving a presentation. Is this the right Jake or is that a different Jake?
That's me.
Awesome. So, yeah, we'll get started on that in a bit. In the meantime, I guess I'll give a quick update on Wallet Test Framework since that's at least something I can talk about. So we have almost finished our grant. We run out in about 2 weeks, actually. And then we're still looking for funding for our next year. Hopefully, we'll get some. And for our next year's roadmap, we're going to be working on 4337 wallet support, Wallet Connect support, and a few other little interesting projects. The past couple of weeks, we've been working on reporting. So generating automated reports of how wallets are performing, so we don't have to do those manually, and that's coming along nicely. That's about it for updates on Wallet Test Framework for now, unless Nikki's here and has anything else to add. But if not, I guess let's hand it over to Jake and let's learn about some wallet experiments.
Cool. Thanks, Sam. My presentation is going to be short today, but I will go over a little bit of what we have been working on lately, mainly on ZK email account recovery. So let me do. Nope. Okay. Can everyone see my screen okay?
Yep.
Yeah, looks decent.
Yep.
Cool. Yeah, so I'm Jake CT. I am the project lead for the Wallet Account Experiments team. We work as part of privacy and scaling explorations to help mainly promote the scalability of the Ethereum ecosystem. And so we do that through kind of prototyping and working on things on top of account experiments. You may know a previous project we worked on called BLS Wallets, which was much more focused on the kind of compression side of transactions for rollups. So without further ado, kind of jump into two things we're currently actively working on. ZK email-based account recovery, and then also user op compression for rollups, which has changed significantly with the Denkun upgrade. Cool. So what is ZK email recovery? And essentially it's the idea that we could take an email, which from someone's provider, like Gmail, Outlook, something like that, and we could use that email to actually authenticate and authorize someone to recover an account. And so I've thrown together a pretty high level diagram of how this actually would work and how we're currently working on building this out with the ZK email team, which is another team at PSE. So basically, you have some email provider who is sending this email. That could be Gmail, it could be Outlook, it could be your own email you're hosted. And one of the cool things about all these emails is they are all asymmetrically signed by generally asymmetrically signed by a DKIM signature, and that key is stored somewhere in DNS. And so we essentially have this signed message payload where we can say something like recover some account to say some new owner. We know who it's from and we know it's signed. So we take that along with a salt, which helps you obfuscate the email address on chain because you do need to store that. We don't want anyone to see that. And you can basically do one of two things. You can either have a centralized service that you get these emails at that is generating the actual proof over the email using the ZK email kind of circuits and tech, and then submits on chain. But this relayer is a censorable point because it could reject certain emails, and it can also, because you're sending it that obfuscating salt, it can see everyone's email address. So essentially, you have to trust that this relayer you're okay with it knowing that piece of like personally identifiable information when you're processing this recovery. The other way you can do this is you can take that email with those signatures and you can just generate that proof natively. So you could do that inside of a browser or some other app. This tends to be a larger proof, and so it tends to, I think locally, one of the other email verification circuits took about, I want to say 10 or 20 minutes locally to generate that proof. And so it just takes a long time. But the nice thing with this is a user can do all of this locally on their own machine without having to rely on some third-party service and then just submit themselves. Either way, you're essentially taking this email that is requesting that you change the owner of an account or rotate the keys. And from that, we get this nice proof that hides the contents of the email, but still lets us prove certain attributes about it. Just a quick check. Does this all roughly make sense?
So in the local proof generation thing, you'd send an email
Yes.
to yourself and then get that email and put it into your browser and it would generate a proof based on that, or?
Yes, I have not actually seen. I don't remember the exact use case. I think ZK P2P is one of the other projects using this. They're using it as an on-ramp through Venmo. And I believe they have a local option. They're working on it. I have not seen that, but yes, you would send yourself an email. One thing I will note is, at least in Gmail, if you do a loopback email send, it generally does not sign the email. It's a very like bare bones email template with no DKIM signatures. So you probably would still need to send the email somewhere else in order to get it properly signed by Google.
Okay, that makes sense. And obviously this has the problem that your keys are technically owned by your email provider, right?
Yes. So
Yeah.
we can get a little bit more into that, but yeah, basically the you have to assume that the provider, obviously you're trusting them as being a good email custodian. You also are going to be trusting I will get into the DNS stuff in a second. What was the other thing I was thinking? Yep, that the email and they signed it correctly. And then also that the account is not compromised. So there could be cases where you may temporarily lose access to, say, a Gmail account because you got hit in a phishing attack. And so we can use things like in the next section, I say like a time lock to basically set up a window in which like we will do this rotation. So if you're able to say get your Gmail account back from the person who phished you within like a day, if your time locks up to 2 days, you could always cancel them like attempting to take your account. Cool. Anything else before I move on? All right. So then what actually happens on chain, which is this is the part we are still actively working on with the ZK email team, is you essentially have that email proof as your payload to a recovery, transaction or user operation. And so you're going to go to your account, usually the 437i account, or some module that's attached to that account that is authorized to do recovery. And it essentially can go out to this email auth contract. There's also an account recovery specific one that has specific functions you need to call on it. And it is linked into a on-chain DKIM registry. What this basically is every email provider has one or more generally DKIM keys they publish to DNS, and they are kind of separated by these selectors. And so you essentially have to have some Oracle process or off-chain entity that's pushing these DNS updates into some DKIM registry contract. And so that is another point of potential kind of centralization risk or like places where things can go wrong. So for example, you could imagine that someone pushed a malicious, say, DKIM update to try and pass some email process they're going through. Or maybe there was just something that went wrong. So this registry, I think right now is mainly only being run by the ZK email team, but in theory, anyone could run any registry they want. So even if you don't necessarily trust the DNS updates that someone else is doing in the registry, you could always run your own or have ways of like, for example, having a per user override that allows them to override what key they want to use for verification. But that still is a place where we're taking that off-chain DNS data and we have to push it somewhere for this proof verification. Anyways, so then the recovery process will go through, and then eventually goes to the ZK email verifier contract, which is generated off those circuits. And this is actually what's going to go through and check that for that DKIM key, that the email was signed properly from that from the provider. It's going to check the subject to make sure it matches. Hey, yes, we're trying to do this recovery operation on this account to this new owner. And then you might also check that the from is going to match the salted on-chain value that we have, and then also some things around timestamp, as in because you may not want to say let a very old email proof trigger account recovery. So yeah, that's kind of the flow we're looking into and building out right now. Any questions on this?
So I think that looks really cool. What's like the main use case for this? Like who's looking to authorize Ethereum transactions with their email?
Yeah, so I would say that this is not authorizing any general Ethereum transaction. Um, there are going to be issues, especially with 4337, um, with having stateful access during that validation phase. And so from what another, I think it was Salil on the ZK email team looked into doing that. And there were just some complications, and at least at that time, in terms of what 4337 would and would not allow during that validation. In terms of like the actual like product use case for this, I think the most common one we've seen is people who want to set up guardians or people to help them recover or rotate keys that don't have Ethereum accounts at all. So you could imagine that if you have a family member or someone else you trust, they would be able to help you potentially recover your account without having any sort of crypto account set up. And that would be the case where like they would either go through a relayer that say like that wallet was providing that would help actually get that on chain. Or you can imagine situations where this user op with the email recovery maybe has like a paymaster associated with it. And if someone's calling recovery for this specific, wallet or account, you could use a paymaster to subsidize the actual sending of that. So the end user who's sending the email has no idea any of this is happening in the background.
That's really interesting. Okay, cool.
Cool. Yeah, so that's kind of on that. So we are currently building this out with the ZK email team. I believe Soul Wallet already has a implementation of this using some other circuits they wrote. And then we're also looking at doing example modules of this for, I think right now specifically Safe, and then the 4337 simple account. But we're also considering other module specs like 6900 and 75 or 7595, I believe, is the other one, as well, for just kind of providing implementations of this for different account ecosystems. Cool. Yeah, and then so the second major thing we're working on Wax aside from this is going to be user op compression. And the thing I can basically tell you about user op compression based on some research my colleague Andrew has been doing. I unfortunately didn't bring his notes because I think he might still be actively working on them. But the TLDR is that Denkun and 4844 have basically made the L1 costs of rollups pretty much zero. I think it's 1 GUI per byte currently because the blob space is currently underutilized. And so any compression we could do on this. So for example, if we take a look at what this compression actually does, where we are taking a very large amount of data that we normally have for like a user op. Note that this is for ERC 4337 version 0.6, not the latest 0.7. And you can basically shrink it down to a much smaller set of.
Could you increase your font size a little bit here? It's very blurry.
Sorry.
There we go.
That's okay. Yeah. So, taking a paymaster and data of a specific length and then shrinking that down to, let's see here, did we get that down? Yeah, there's no bytes in this case because we basically just removed all the zeros. We're doing all this compression, basically just trading compute for call data in the actual data that's rolled up to L1. And since that data is basically free at the moment or very, very cheap, this kind of compression doesn't, it actually ends up costing more because you're using more of that roll-up L2 compute. And so the TLDR is just in the current fee market and going forward. unless blob space starts being used more, gets much more usage, it's not really worth compressing a lot of that data, including the signature stuff. But if you're interested in learning more about that compression work, you can find it in our main repo under the compression packages. And the link I posted, which I'll share all of this in the chat as well, goes over the kind of size savings you can get if you really aggressively start compressing the different user op fields and different things like the entry point in it.
So
Yeah.
are you looking at like a general purpose compression? Is this like deflate or gzip, or is this something specific to
Yes. This is specific to specific accounts. So in this case, it has to be specific. It's specific to this is for sending Ethereum. And then you also have like compression you can do on tokens. So this would be an example of like translating, say, like a token from a index to an address. So doing like a lookup scheme, or using a construct like a pseudo float to shrink the amount that actually is being sent into a smaller value. So in this case, it's very application specific compression. Most rollups already do gzip or some other general compression by default on the call data they're submitting to L1. So it would not be very valuable to just do another layer of like say gzip on top of that.
Okay, that makes sense. Yeah. No, that's cool. Thank you. Yeah. So yeah, thanks again for coming out and giving the presentation. I think that's really informative, and I don't know, I'm pretty excited about anything zero knowledge related, so I appreciate that. We don't really have anything else formally on the agenda for today, so we can end it here. We can hang around and discuss random topics if anybody wants to bring anything up. But I yield the floor to anybody else if they want to talk.
Might be a dumb question, but like given that you said the like L1 costs are like quite low, like doing these compressions, like do you have any rough ballpark like how much it would actually save? And like given that like you're doing custom compression like algorithms, like is that do you think like that's necessary?
Yeah, I think in the case of really common operations, it is. So, for example, that ERC20 compression, you have to get much more, if you want to get into much like higher data savings, you have to get much more specific in like what fields you are shrinking and in what way. Like, are you shrinking a long value padded by zeros into just a smaller like representation of that, or those like address registries? The the main cost before dank sharding of a lot of transactions was the actual call data is being rolled up primarily to the ECSA signatures, having to have that R, S, and V component in every single transaction that you post as part of that call data. If you're able to, one of the things I did not mention for the compression is we also have some of that happening via BLS signatures. So the ability to take, I think an ECDSA signature by default is 32 bytes, and a BLS signature is about 64 on the curve the EVM supports. And so basically, if you get above 2 ECDSA transactions, and you would instead be able to use one BLS signature to represent those both, obviously the savings just stack up from there. In terms of really trying to shrink that call data that the rollup has to push up. Before the dank sharding, there were cases on Optimism because their compute costs are generally lower. That, let me see if I can find in the doc the actual stat. It was about, I think, 2x lower or more. I'll have to find it. But because the now L1 data costs are so low, you're basically just wasting compute on shrinking those values. Does that answer your questions?
Yeah, yeah, that's a good point of view. Because like right now, is it? Yeah, like I haven't looked into the data yet. So like if we see the cost distribution as like the L1 storage and L2 storage and L2 compute, yeah, would be interesting to see okay like which ones are like yeah the most expensive, and then yeah, like maybe optimizing on that. But yeah, like overall, I guess like the L2 storage is something we can't do anything about. Like we can, because yeah, like if you're transferring tokens, yeah, like it's just going to change the same storage values. Like doesn't matter how you do it. So it's
Hmm.
yeah, it's more around just like how efficiently you are able to do it, um, like while posting it on L1.
Yeah, and what I'm seeing in the numbers of the original doc Andrew shared, which here I'll just post that real quick. So this was pre dank sharding. It looks like it in one of the examples for say the Arbitrum transfer, it cut it by about 80%. The actual like dollar cost because of those data savings. So if we see more L2 activity or more blob space usage, this could still be useful in the future, but it doesn't really seem feasible now.
Okay, makes sense.
Hey everyone, I'm Lucas at Coinbase. I was hoping to talk a little bit about a proposal we recently put out for new wallet RPCs. I don't know, Sam, is
Yeah,
that
please do.
okay?
Yeah, go for it.
Okay, cool. Awesome. So I'll just share my screen. Okay, can everyone see this?
Yep.
And I'll also drop the link in the chat just so you can go and read it yourself if you want. So yeah, basically, we recently launched a new ERC-437 wallet, and we kind of realized, the UX for 437 wallets is really promising, but the problem is that beyond like onboarding and things like recovery, the story is kind of not that compelling because the UX, once you are in the context of an app, is pretty much the same. So we realized that it's kind of time to think uh, about how apps can better communicate with wallets and take advantage of like new UX enhancements. So things like batch transactions and sponsored transactions via paymasters in this case. So we put together this proposal for 4 new RPCs. One is wallet get capabilities. This is for like open-ended communication between apps and wallets to find out the kinds of features that a wallet supports. So, for example, understanding if a wallet can support a paymaster or batch transactions. Wallet send transaction. This is kind of like the new ETH send transaction. This allows you to pass an array of calls so that wallets that can support submitting multiple function calls in one transaction, so like in a user op in the case of a 437 wallet. And it also allows you to pass a capabilities field so that you can talk about the capabilities that a wallet support. So a simple example would be like passing a paymaster URL so that the wallet during user op construction knows where to get a paymaster and data. Wallet get transaction status and wallet show transaction status. These complement wallet send transaction, and it's for getting the status, which we define as like a pending or confirmed enum and a subset of a transaction receipt. And showing the transaction status is delegating to the wallet to show the information about a transaction. These are heavily inspired by EIP 5792, which is was around primarily just sending batch transactions. So we took a lot of inspiration from that and kind of extended it so that you can kind of think into the future of like not just paymasters and batch transactions, but whatever else might come up. Yeah, so I won't go into the details too much of the spec, but that's kind of the TLDR. And I guess a few of our guiding principles are like, one, we don't want to have apps think about like user ops or regular transactions, right? They should just be able to call one standardized API, and then the wallet should be responsible for deciding how that lands on chain. And we also kind of wanted to leave room for things that go beyond 4337. So like right now, this is geared kind of towards 4337 because we talk about paymasters a lot in batch transactions, but this like capabilities thing we think can be useful going forward when there's some new type of wallet implementation. So yeah, that's kind of like the high level overview. Would love to hear like any initial thoughts, reactions, or happy to also like answer any questions or go into more detail if anyone wants to know more about any of the methods specifically.
Hi, Lucas. So I obviously just started looking at this, but since there's currently a bit of an active conversation going around EIP 3074 and 5806, like different capabilities that allow EOAs to have smart contract capabilities, including things like batch transactions and sponsor transactions. I definitely think it's worthwhile to just check that this works well together, right? So like to adjust this so that it basically works for both use cases in the same way, so that 4337 and, for example, 3074 accounts can basically interact with the same way. I think it's totally doable. I just didn't check if it's already tailored for that.
Yeah, definitely, and that's definitely one of our like guiding principles is that developers should be able to call these RPCs and expect that wallets land their transactions on chain as expected. And the idea is that it's kind of up to the wallet to make sure that when they receive these calls, that they handle them accordingly and make sure that the calls land on chain. But yeah, definitely something that we have in mind.
Yeah. For example, like with the paymaster, like what are the parameters we need to make sure that are in there so that all kinds of like calls work, right? That's kind of like what I'm thinking about.
Yeah, definitely. And the paymaster stuff is definitely something that we need to flesh out a little bit more. We actually have a follow-up doc on that specifically, which I can find and send here. But yeah, the idea is that we're thinking that capabilities should kind of be community defined. So yeah, to answer your specific question, like the fields of paymaster communication are still kind of up in the air, and yeah, we want to make sure that we get that right so that it works for all implementations.
Awesome.
I have like a small question. So like when I try to like fetch any kind of capabilities like using this AIP, and like just thinking in terms of like as we go forward, like there might be like new kinds of capabilities that might come in. So like, how do you think about like should this AIP contain the specific types of fields? Okay, like maybe paymaster and all that stuff. So like, do you want to like impose that? Okay, like these are the fields that will be used, or is that like an open-ended thing that like, because yeah, that's like a challenge that I could see. Is it?
Yeah, definitely.
Yeah.
Right now, we're kind of thinking that it should be pretty open, and we've discussed kind of the idea of like WIPs, like wallet improvement proposals, where the community can come together and like define new capabilities and sort of align that way. But we're currently not planning on imposing any specific fields per capability.
Makes sense. Yeah, like this is kind of where the dApps like like we'll have to figure out like if this is something that like gets accepted like by like a lot of wallets, and like then just need to make sure that like each wallet like follows some sort of like standard like across like different capabilities. Otherwise, like dApps might uh, would have to like handle like all the complexities of like maybe if the formats are different across like different wallets for like the capabilities. But overall, I guess, um, yeah,
Yeah, definitely. Yeah, and I think the details around that can be defined like as part of the definition of capabilities.
Mhm.
But yeah, definitely another kind of guiding principles. We want to make sure that we can get things right for any wallet implementation.
Makes sense.
I'm also I found the other doc that we've put together on thinking more about like the paymaster capability. If you're curious, I just dropped it in the chat.
Yeah, sounds good.
So I had put a few comments on this document a while ago, and I
Yep.
completely forgot to follow up. So I'm just going to follow up now.
Sure. Yeah.
So I think the one that stands out the most to me, like as a low effort change, is just changing the name of transaction. So don't call it wallet get transaction status, but something else. I think the name is a little misleading. Um,
Yeah, so on that one specifically, I actually also kind of forgot to follow up and recently responded. We have actually been thinking about changing um, the spec so that multiple calls must be um, executed as part of one transaction. And I guess like a side effect of that is that the name is kind of no longer misleading. So curious if you have thoughts on that.
so if each action inside of this bundle, whatever we want to call it, gets a unique identifier, then if you can later call get okay, no, I guess this works. So yeah, I guess transaction makes sense then. Yeah, that's
Yeah,
fine.
I guess curious if you have thoughts on the I guess kind of the downside is it could be viewed as like a little restrictive to like EOA wallets, for example. But I also saw your comment around like having a field so that you can specify the like atomicity of this. But um, yeah, I think the kind of cleaner solution is to just say if you're going to pass multiple calls, they must be executed atomically, so that developers don't have to reason about like, well, what are all the possible ways that this could fail? Um,
Yeah, I think like so. There's a couple reasons why I like the atomicity field, right? Because then like anything that allows the dApp and the wallet to communicate more clearly about what they need, I think is useful. And in this particular case, like there's a difference between bundling because it saves gas. Like let's say you're swapping like a bunch of tokens and you don't really care as long as they're all sent together and like you don't care if they fail or whatever. You just want to save gas on the transaction. That's very different than like I want to swap millions of dollars and there's like several hops in this thing and I need them all to work or all to fail. And being able to communicate that kind of difference between the dApp and the wallet is going to be very important.
mhm. Yeah, that's fair. Um, yeah, gut reaction is I feel like a little hesitant to put that in like the core of the API. So I like lean towards maybe making that a capability or something. But yeah, can
Also,
work
like
with
So
that.
there's uh, like like I was also thinking about like these kind of cases where say like if you're trying to do like batch transfers, like in that case you might need to do the approvals at first and then the transactions. So like it's not exactly atomic, but like uh, it's sort of like stepwise that like you need some transactions to complete first and then only you can do others. And like I do understand like this is not exactly batching, but like uh, it's sort of an intent that like I'm approving that like you can go and ahead like go ahead and transfer these things. But uh, yeah, I guess like yeah, this might be outside like what this EIP is trying to like sort of solve. But yeah.
Right.
so I think it could be done with a capability as long as it's possible to do it mandatory. Like if the DApp says like either you fail this RPC call or it completes atomically, then that should be fine. But if you can't express like binding requirements on capabilities, then that's kind of a problem.
Yeah, I think that's fair. And currently, in the draft we're working on, it's the former of what you just said. I think where if it cannot be executed atomically, then the wallet should revert. Um, yeah, and then we can think about how to include like more like sequenced transactions as a capability.
Well, even the difference between atomic and like like Flashbots versus like smart contract wallet, because Flashbots can guarantee atomicity except in the case of a reorg, which is a looser guarantee than some people might want. I'm not sure like if that needs to be represented or not, but yeah, there's a whole bunch of levels to this.
Yeah, that's fair. Okay.
And like Vasa said, there's also sequencing, right? So if you have like a bunch of like if you created like a numbering system where you could say like all transactions numbered 1 have to complete and then all transactions numbered 2 have to complete, and like you can get very complex with the sequencing stuff, and I don't know if that's easy to represent with this or not, but yeah, I mean for just a simple batching API, I think this is pretty good.
Cool. Any other questions or comments?
Like nothing specific to EIP, but yeah, like we are also like working on like on OpenSea wallet, or like we are working on like some ideas where like we want to batch things, but like our problem statements is that like it's very much sandboxed like wallet environment, like we're not doing it like outside OpenSea at this point. So like it's yeah, like while we have like not thought about an EIP, but yeah, like this is something that we can like sort of contribute to in terms of because yeah, like we also want sort of an experience where okay, you express an intent to do something, and then uh, yeah, it can be opt-in, but like yeah, like we want the least number of clicks that the user might need to have like to do anything. So yeah, like this is something that's like a good direction, like not just for like because the problem is that like we can only power that experience for our own wallet, but like for any other external wallet, it's a like very totally different experience. So like if
Right.
we have like some sort of a common ground here, like yeah, then it's good experience with like any wallet.
Yeah. Cool. I'm glad to hear that, and yeah, would love to kind of loop you into the conversations more. It sounds like you guys would have good thoughts on how we can do like the difference between like sequenced transactions and like batch transactions.
Yeah. Like, is there a pull request for this? Like, I haven't checked the current one.
Not yet, but
Okay.
yeah, I can follow up.
Okay.
Anything else? If not, that's okay. But thank you everyone for the comments and the feedback. This has been very helpful.
Thanks for sharing. We appreciate it.
Like, I guess like if we don't have anything else, and like I've been working on like a L2 beats for wallets, and like I don't know, like I know like there's like bunch of other implementations of it, but it's more of a learning thing for myself where yeah, like just like try to like work with like different wallets and try to understand okay how everything works like within their wallet. It's so like most of the wallet comparison website, they only focus on like features and stuff. Like I wanted to do a like more holistic things. Like if you have seen like L2 beats, so like it has like different versions of it. So like you can go to the security or risk analysis or like the maybe yeah. So like the categorization of like different tables is different, but like for every uh, page, sorry, uh, yeah, like it's I'll send you like on the chat. Uh, but yeah, the main thing is that okay, there's like a main page for each chain, and for each chain, like just a second. Okay, yeah. So for each, so like for each chain, you have like a single page which has like every detail about that, yeah, chain, and then different categories of like the table. So like maybe security or like the overall TVL. So like they'll link to like different sections of it. So like it's more holistic in some sense, and like it's not like a ranking thing that which gets quite subjective, like the way you're like ranking things. So like I don't want to like rank any wallets. It's more around okay, like just like an objective comparison of like the
That sounds like a super useful project. Did we lose you? Did I lose sound?
No, we can hear you.
All right. Not sure if Fast is having technical difficulties or what, but or if I'm having technical difficulties. But yeah, I think that's a really cool project, and if you can link the results, I think that'd be useful. Oh, no worries. It happens. Um, yeah, so I guess with that, unless anybody else has anything to bring up, I'll give you all back 15 minutes of your time, and we'll see you in a month.
Thank you.
See you.
Thanks, Sam.